Hello, everyone. Welcome to IoT Live Lab here on Industry 4.TV. This is a session where we explore tools and techniques for building the connected factory. So if you're new to this channel, make sure that you subscribe and also make sure that you set your notifications on so that you can get notified each time we go live. We do this every week, every Thursday at 6 p.m. Central European Time. So make sure to subscribe and keep your notifications on. So today we're going to be talking about how to create a semantic digital twin modeling using Node-RED. And my guest today to help demonstrate that and talk about the project that they're working on is Charles Steinmetz. So Charles, I'll let you introduce yourself.
Okay, thank you, Kusai, and hello, everybody. My name is Charles. I'm originally from Brazil, and currently I live in Germany, where I do my PhD in computer science, and I work at University of Applied Science Hamm-Lippstadt as a research assistant. And yeah, first of all, thank you very much for the invitation, and I hope we can exchange some ideas and talk about future possibilities.
Sure, absolutely. So in for whoever is on the call here who wants to ask any questions, feel free to drop the questions on the comment section here. We're going to address your questions as we go along, and please let us know where you are joining us from and whether we are audible and visible. So without furthermore to do, I'll let Charles take over.
Okay. Yeah, thank you. Let's see. I hope we can see my screen.
Yes, we can.
Good. Okay, good. The idea of today is to present a little bit of our research at university, and again, this is about more about research and ideas more than a ready-to-use product. So our idea is to show what we are doing research and also collect feedback from other people that are interested in this work, and maybe some collaborations in developing something together. Well, the title of my presentation is Semantic Digital Twin Models using Node-RED. So I will dive directly to one of the motivations, which is what the Industry 4.0 is bringing is connecting different parts of your system, allowing different parts of the system to communicate. And this also puts together different stakeholders with different backgrounds. For example, an embedded system design engineer could share information with an application engineer or application developer or a system management person. So you could see that this new revolution is also bringing the possibility that different people with different knowledge can interact and communicate, and they have to share information and share their knowledge. And this is one of the motivation that drive us to develop what I'm going to present today. um, Talking a little bit about digital twins. So nowadays with the digitalization, we usually want to have a digital version of your system for many reasons. One of them could be that I want to try new configurations or new things, and I don't want to try directly in the physical world. I don't want to break something. I want to have the possibility to give a Control Z and go back and roll back before I break something. So the concept of digital twin uh, sometimes is misunderstood, but here I bring one picture that compares, for example, digital model, digital shadow, and digital twin. And here you can see the arrows. When there's a dot line, then it's a manual data flow, and when there's a continued line, then it's an automatic data flow. The digital model doesn't have much automation. As you can see, the update from the physical world is sent manually to the digital one, and the same way back is everything is manual. And the digital shadow means that you have a virtual representation that is automatically updated from the real asset, but to send back to the physical world is still manual. And the twin, as the name say, is that you have a virtual twin, a virtual instance of the real world thing, and the connection between the object and the digital and the physical is everything done automatically. So you get data from the physical asset, and you send probably comments and adjustments to the physical back. So that's the idea of having of the digital twin. I think it's quite popular nowadays, this concept. Here, comparing to model-based design approaches, also related to software development also, or system in general. The idea is that you model your system first in different modeling languages depending on the use case, and then you generate the instance in the real world. So these models here, they specify their real world instances, and these real world instances send data to the cloud. This is what is mainly done nowadays, also what should be done at least. With the digital twin comes the possibility to have all these models still here. Like you don't you use it in the beginning of the development system, but also you keep them after the product, your instance is created here in the real world. So then your data is sent to the cloud, and you still have the different models with different perspective of your asset, and the stakeholders can have an update overview of your system at any time, together with the models that they have created in the beginning. With this, with this information, with this data, they are able to send back adjustments to the system and do improvements and so on. This is a comparison with then the model-based design. Now bringing the concept that we kind of created in the literature, we can find several definitions for digital twin, and we try to assemble some of them and create one that can be used from us at least. A digital twin is a combination of models. Here in red, you can see the words here fit to the image. Is a combination of models that represent an observable asset. Here in green, the asset, and from the real world, the asset could be anything that can be observed. It can be a physical thing like a device, or can also be something that is not physical, like a process, for example. And it can be represented in different perspectives. Like this model, this asset can be represented by different models here. It can be behavioral model, geometry model, like a 3D or something. And it's continuously updated. Here it means that you keep track of the properties of this asset, and it can interact with the real world. So the asset can also have actions and event that can influence in the properties or in the state of the asset. So this is one concept that we came more or less combine some of the one existing in the literature. Is not something that is not rocket science. It's more that about it. We try to summarize what is there and represent it in this diagram. So one example here is this wind turbine. You can have different models here that represent this asset. So you have the physical entity here, the physical asset, but you have then this cyber models that represent this physical asset. And the cyber part can be a combination of many models, like a 3D model, could be an automation model, a state machine use cases. It could be even unit tests. If you have part of your software that should behave in some way, the unit test can always check it. And from my point of view, this is all part of the twin, because it helps to check part of the behavior of the system. After we came with this nodes, I presented this in a conference here in Belgium. Then I met one person from W3C, and then he recommended me to have a look here. They have also one standard which at the end looks really similar. At least here, this part of what they have a standard for Web of Things. And one thing can have also properties, actions, and event. And I think this is quite good because we found some common understanding about this. And I think to be always in a standard is it's important also to allow interoperability with other systems. So here we have one method that we provided for modeling and for creating these digital twin models. The idea is that you observe you identify first the observable assets of your system. You can, I don't know, you have your system, and then you can divide it in small pieces that you can observe them and that makes sense to split them and make them unique. And then you can create this model that represent this asset, these small parts that you have identified. And the idea is that you add semantic and the relationship between these parts. At this, after you model them, you add the semantic, the relationship between them. You can add external models because, as we saw earlier, one asset can be represented by different models. So you can add different external models. And when you have this done, then you can configure the communication interfaces, because the idea is your system should be always connected to the real world. And after this, you can then deploy the system. After you deploy, because you add the semantics here, you generate a knowledge graph of this of the piece that you identified here. You have small parts that you can observe that are connected via semantic, and this is represented by a knowledge graph. This knowledge graph can be saved then in a database, and this can be used later for doing inferences, learning algorithms, and so on, and develop applications. These applications here, this here is everything in the cyber world. So the twin is this model, but here comes again that possibility that the twin can send commands and adjustments back to the real world. So I will show later a model, and we can visualize it better in Node-RED. But why then using knowledge graphs? You might be asking yourself. I think especially nowadays that machine learning algorithms are so popular and people are using them everywhere. I think it's quite important if you can formalize and annotate and create a specification of your system that contains semantics. A knowledge graph brings this possibility that you can represent effects in form of entities and relationship between them. Here it's written. So for example, here you have an automotive industry, and you say that BMW is in automotive system. In automotive industry. BMW produces the car iNext, and this is electric car. So then from other side, you have Tesla that produces Tesla S or whatever. And this Tesla S is also a car, electric car. So here, can we say that Tesla is in the automotive system? It's not modeled here, but via this knowledge graph, you can infer that, okay, Tesla then is also an automotive system. This is only one example of how you can um, extract knowledge from a knowledge graph. And coming back, just go back here, sorry for that, but as we see here, we have different stakeholders. Then you may ask yourself, uh, probably the knowledge that these stakeholders have are never mapped between them. It's hard to share this knowledge, and maybe even harder for system to infer something that these embedded system engineers know, but the application person here knows how we can combine these two things. So that's also one reason why we provide this uh, generic language that you can model and represent the knowledge in different domains, also from different domains.
Okay, so maybe before we move on, we just got a couple of questions and comments here. So I think I think it's a comment or question from Russell, right? He says the industry standards layer for semantic data definitions ought to be model based as well, preferable with SysML. So I don't know, you want to comment on that, Charles?
The industry standard layers for semantic. Yes, to be model based as well. Yeah, there are some standards. We also are looking at the end. I will also show some standards that we want to integrate. The idea here is to provide first a generic uh, language that you can model not only industrial things, but it's kind of an ontology that you can represent knowledge in any sectors, or not only industrial, but as you could see here, the idea is to extract also knowledge from people that are in upper layers of your system, not only below, like engineers and something like this. But yeah, of course, I agree that we should keep in mind this already existing standards and at least be interoperable with them, like to have the possibility to integrate these existing standards. Yeah.
Okay, perfect. And I've got another question from Sitaram. So I hope I'm pronouncing your name correctly. So he's asking, may I know whether any attempt was made to combine knowledge graph in Node-RED?
Yeah, this is one thing. I haven't found any other approach that combined it, because Node-RED lacks a little bit. I think Node-RED is great for IoT applications, first of all, but it lacks a little bit on adding semantic to your system. And this is one also one outcome of this project, that it was not the main one. Well, the idea was not bring semantic to Node-RED. It was more to implement our concept of digital twins. But then I think in some way we also can bring semantic to the Node-RED. Yeah, and yeah, but coming to the question, I don't know if there is already one. I didn't find at this time when we started the project. I didn't find one that already have combined knowledge graph with Node-RED.
Okay, perfect. Yeah, so
Yeah.
I mean, if there's anyone else who've got some questions, please feel free to drop them on the chat there. We'll answer your questions as we go along.
Yes.
Okay, so I think before we move on, let's look at what John is saying. John is saying knowledge graph are converted to JSON format for working in the flow. Time series data are hard to do with that. Do you try with NGSI LD?
Yeah. No, I haven't tried yet, but this is correct. Because the knowledge graph should contain the latest state of the system. How you started the time series data, then you should handle it in another approach, I would say. The knowledge graph itself I'll show you later one example. it contains the latest state of the system. But it's crucial. Of course, it makes a lot of things, and it's really important to track to save the data that is coming every time. And but again, it's one project, ongoing project, so there are a lot of things still uh, in the road to be implemented. So again, it's more about a research project that is being developed, and I look for these great ideas to also guide us, and also why not help if you it's an open source. Later I will show the link, and it would be great to have also effort and help, suggestions, anything. So coming back
Yeah.
here, sorry.
Yeah, sure, absolutely. So I was saying, yeah, I mean, one of the things that would really appreciate is feedback from the community with all the suggestions. So I've also put a link to the GitHub repo of the project that you can check out after this call. And then please feel free to provide some feedback and help improve this project. Yeah, so just
Yes.
go on.
Yeah. Before I forget, also, I think it's a great opportunity for us researchers to get in contact to the industry, and like to minimize the gap that sometimes exists, and also to grab ideas that you need, or also maybe you get some ideas that we are developing. I think this exchange is very important. Just parenthesis. Thank you. So why Node-RED? Then at first, we our research is more about defining how we can represent digital twins. But why then Node-RED? The digital twin is built on top of the IoT. Like you need all this IoT infrastructure. Like you need access to the physical world that the IoT can provide. Like you also have these cyber physical systems. There are a lot of concepts in the literature about it. And then we did some research to find out what is being used for developing IoT projects, and we found Node-RED. Node-RED is a great open source tool. It's kind of a platform that you can build IoT applications. You have thousands of nodes already built by the community, and from my point of view, this is very important to have a good product at the end. Also, if you have a community involved, an active community, and it's also one thing that makes it possible that our approach later could be used in industry, because many companies or maybe projects have been developed already with Node-RED, but maybe they don't have this semantic layer that we are providing or that we want to provide. So the idea is that we provide something that can be just built on top of what is existing already, that you don't have to rebuild everything from the scratch. You just have that thing, and then you map all the parts that you think make sense for your use case, and add the semantic, and you already have everything implemented then. So that's, of course, there are many other reasons why Node-RED might be suitable for that. But there is one thing that doesn't fit so good with Node-RED. I will tell later. Now, actually, that this approach here changes a little bit the behavior of Node-RED. If this is the best approach or not, I'm not sure yet. But this is how we implement it now. We defined these nodes that I presented earlier, like how a digital twin can be composed, like the assets, the properties, actions, and events, the relationships, and the models. So here there is an example, like there's an asset that has a relationship to another asset. This one has a property here. This other asset has an action. It has a model. So the idea is to represent the structure of the system and annotate the semantics between them. Why it changes the behavior? Node-RED usually works in flow. It's a flow-based tool where you have an input and data comes from input and goes to the output. There is always a sequence that that occurs like every time you have one thing after the other. We had to change this because we also introduced this DT graph. What this graph does is it watches the whole model and generates output every time there is a change in the model. The change could be the structural change. Maybe you change, you add another property, you add another asset or something, or it could be data output here. When, for example, this property has been updated from the real world, like temperature was red, or I don't know, something happened, then you have here one event. This node here also generates a cipher string query that you can then connect. For example, Neo4j, we have selected Neo4j, but there are many other knowledge graph databases. And yeah, then the structure here when can be saved also with the latest state of the system can be saved and in a knowledge graph database. Also, another good thing of Node-RED is that it can run on devices with small capability, like Raspberry Pis. It means that if you have in each machine a Raspberry Pi, you can have different instances of Node-RED running, and it allows you to have distributed model. So every machine could have its own model. Like you could also have a main machine that everything is connected or not, or each one is connected directly to the database. This is architectural decision and use case dependent. But the idea here is that to show that this model can run in parallel, so you don't have a huge model that has everything, but they are at the end modeled in the same language, in the same standard, and saved then in the same place. So maybe I'll show you quickly one example here. So this is Node-RED. I think most of you are familiar with. Here there is one really simple example that you have, for example, two software tasks and a periodic task schedule, and then for example, here they are assets. These two, these green parts are assets, and there are properties like the measured execution time and the time period. What it says here in this model is that these two tasks must fit into this periodic task schedule. So it's really simple, but only to show you what is our idea and which direction we are going. And I think it's very important if you also give feedback, or if you see a better approach for that, please feel free to share it with us, and yeah, or also contribute to the repository. Good. When you deploy the system, there is then this output that shows you the cipher, but the cipher we will not have a look because it's a long string query. But you also have some informations about the project, metadata actually. You have your assets, and these assets then in this case have properties and yeah, and also the relationship. Like you could see here, there is a relationship between these two assets with this one. Then you also generate this. If you use here this tool, it's better to visualize. The cipher code is here. Then you have the model, you have metadata related to the project. You have the assets, and their properties and their relationships here must fit into. Oh, sorry. And then you have the origins and the targets of the relationship. Like is from the software task 1 and 2, and the target is the periodic task. It's exactly what it's shown here. Here we did a tricky part, which is because it was not, it had some bug, but we had to fix this this tricky way, but it's not supposed to be like this. In this example here, we show that we can also connect like with this output directly to Neo4j. And if I show you Neo4j here, then you can see the idea here is that you have this knowledge graph that contains always the latest state of your system. Yeah. So this trick here should be gone in some days. It's only a bug that we have. Good. So coming back here for other examples that
So
we have
maybe
been.
quickly before we jump into the other examples. So we've got some question in the comments. So Mechatronica, great. Thank you for the share, Charles and Kudzai. Thank you so much, Mechatronica, for attending. And then we've got Mohammed who's asking, is Node-RED is time-stamped data to be analyzed after recorded in right way? I'm not sure if you understand the question.
Analysis after recorded in right way. I am not sure if I understood it correctly. Could is Node-RED
Could you,
has time?
could you please clarify, Mohammed? Can you please just clarify your question?
Right way. Time-stamped data to be analyzed. Yeah, I'm not sure if I understood. I'm so sorry for that. But yeah, you can have techniques for generating timestamps. Yes, I think so. I'm sure about it. But this is something that you should take care of. If you have real-time related applications, Node-RED is a runtime tool. It isn't as far as I know. I'm pretty sure it's not real-time, hard real-time, at least because it runs on top of new Node.js. Yes, it's a JavaScript um, framework. So a JavaScript and an engine. So it's not hard real-time. So if you wanna have a precise timestamp, you should take the timestamp on the edge device, or the device that produces the data. But if it's not so critical, you can, of course, get here the timestamp via Node-RED as well. Depends on the application then.
Okay, perfect. I think that's the question that he had. And what? Okay, we'll put the link to the repo in the chat. Thank you.
Yeah, thank you. Yeah, also ideas and directions would be very appreciated. So here we have other examples also that we have worked on. Here's one example of an industrial valve that has some properties like temperature level, pressure, vibration, and this valve also can open close. And this valve is part of the refinery that belongs to Petrobras, for example. It's just a random Brazilian company that I selected because I'm Brazilian. And so here you can see that you can annotate and you can create this semantic model. Another thing I forgot to mention earlier is ideally you should define, because imagine you already have your IoT system implemented on Node-RED. You only want to have this semantic layer on top of this. Ideally, you should keep this model, the semantic model, only with the nodes that we have provided, and handle IoT details before. Like you can add this input nodes here, and this input node here is, for example, here IoT sensor. It opens another flow that you can implement all your IoT specific things. And here only data comes. So you keep your model clean, and it's also is a kind of a standard that you don't mess things up. If you start to do like I did in my example, just adding more nodes that are not related to this digital twin section, you can mess it up quickly. So here I added the input only to show an example, but ideally you should only use these nodes here in this model, so you keep it in somehow clean. Yeah, yeah. There is a question. If
Yes, they're asking the notes that you're using, are they available on GitHub?
yes, yes. This is also one good thing of Node-RED, that it's an open environment. I'm not sure, but if all packages are open, but ours is open. And of course, we are researchers. We sometimes don't publish everything before we write a paper about it. So our ideas always have lead to a scientific paper that we present in scientific conferences. But we would also appreciate to have feedback from the community, from industry, and so on. So that's why also we open source everything. And yeah, if you want to use or try it out, please feel free. Good. Here's another example that we are working on currently. There's this nice Fisher technique industrial plant that we are trying to map into using that language that we propose, these nodes that we propose. And one of our students is developing a state machine. So you can model the system using the nodes that we provided. And as you could see earlier, like here, one asset can be represented by different models. That's our concept of digital twin. One of these models, in this case, will be the state machine. And this state machine should be a way of, okay, of course, to see, to verify which state the system can be in at, and also to visualize, graphically visualize where the system, what is going on with the system at this time. And here there is also a figure, image that shows, like you have the physical world, then you send data here. You you have your finite state machine, and then you generate states, like a stamp of each state of your system. You generate a stamp. Look here, at this timestamp, the system was at this state. Afterwards, if you want to roll back and see what happened, this goes in the direction of the time series data that was mentioned before. Afterwards, if you want to go back and see what happened to the system at this timestamp, you can go and see the exact state of the system. Here is another example, only to show that with this language, these nodes that we are providing, we can model different levels of abstraction. The granularity of the system always depend on the use case, of course, what brings you value or not. But it allows you, for example, to model a device with its properties, methods, or actions, events, everything here, and run it on a Raspberry Pi, for example. But it also allows you to to model, to specify the structure of the system in a higher level. Like, for example, pump one that is defined here, it is part of the sector one. It feels and is connected to the tank one. The technician one is responsible for this tank one, and well, detection 1 belongs to the sector 1. As you can see, I'm not good with naming, but the idea is that you can also represent higher level of, of, of your system. And also you can, for example, represent um, processes. For example, check level belongs to the sector 1, and fill tank is another process that depends on check level. Here you can, for example, also query what processes or what tasks are depends on check level, for example. Then if you want to fill the tank, what should I do before? You can semantically write it here and not hard code it in your system. Yeah, it's one possibility. Good. Then coming to the end of the presentation, I hope it was not too boring. I want to point out some points that we are working on and what we plan to work in the future. And of course, again, if you have ideas, please share it with us or let us know. Maybe we can cooperate.
So
We are.
maybe
Oh, sorry. Yeah.
sorry to interrupt. So maybe you before you jump into the feature work. There's a comment or question that maybe you could address.
Okay. This is my working colleague. Actually.
Oh, nice.
Yeah. Thank you, Mehdi. He is. He has a lot of knowledge in knowledge graph and AI in general. Yeah, there is temporal knowledge graph. Maybe, yeah, it can help with time. Of course. There. Thank you, Mehdi. This is a possibility. It's not been implemented yet, but yeah, it's one option that we could use. Before I forget, also this is not only my work. This is part of my PhD, but a lot of people are involved, and I have a lot of colleagues, also people from Brazil, the professors. So it's not only my thing. Just to give acknowledgement to everybody. Good.
Okay, and
So
we've got a question also, sorry to interrupt, from
yeah, no.
Dr. Rian. So hopefully I'm not mispronouncing your name. Yeah, he's asking, can machine learning not be used to discover the state machine or model through weights? This would make the model context free and then focus on post-semantic tagging. This would reduce the cost time to produce a valid model and not presuppose relationships that would not be modeled
Yes,
effectively, e.g. physics, yeah.
yes, yeah, definitely, yes. Here there is one topic, model generation based on messages. I went to a conference in Stuttgart last year, and there are some people already generating models based on MQTT or OPCUA messages. So that's definitely one future work that we wanna put hands on, because modeling all the system. Imagine your system has, I don't know, 50 machines with, I don't know, 10 properties each. It's 500 nodes that you have to model. Of course, you can create sub modules that works like a class in object-oriented programming. In Node-RED, you can create like a template, and then you can instantiate it many times. This helps, but if you have a machine learning algorithm that can already generate part of your model or the whole model, and you just have to adjust the model, that would be great. And that's something that we are working on. And as I'm already talking about this, there is also the option of having dynamic models, because there could be the case that one asset enter the system, but also leaves, and then enter two others. The models can be dynamic, and somehow we have to handle it automatically. And also regarding generating new knowledge. I was last week in a business trip, and one professor gave a good example. Imagine you touch a heat, uh, a piece of metal that is really hot. Then you touch it and you burn your finger. This is a new knowledge that you have created. So it's something new that, for example, machine learning can create it in the system. But comparing to the human world, you can have like, okay, I touch the hot interface face here, and it burned my finger. So this is a new knowledge that it was not uh, designed before. I could have only the temperature or something like this. And how we can bring this new knowledge um, that is generated to the model automatically. This is also one thing that we plan to work on. Uh, Regarding some standards that are already available in the industrial domain, like asset administration shell, OPC UA, unified namespace, this is, I think, to get into the industry, you should at least support them, like be compatible with them. Um, Currently, our research group works in a project called GaiaX for Ageda. GaiaX, I don't know if you guys are familiar with. It's a European standard, like to create a safe and trusted environment that you have providers and consumers, like providers can provide services and consumers can consume the services. It's an European initiative, and it's been used in different domains, mostly for research yet, but I'm pretty sure this will come in the next months or years. So it's something that we want to already be ready to support and easily integrate in the future. And the final point is that this project is heavily under development, like it's initial phase. So please, it's not something that you should install and replace your system with. Like, you should try it out, see the ideas. I think this was one of the goals of this presentation, is to share our ideas and also receive some feedback. And if you want to try it out, it would be great to see what we plan to do and what is already done, and what is missing to fit your use cases as well. Maybe you have ideas like, okay, to work with me in my industry or mine use cases, I need this and this. So probably you can even do yourself, create a pull request, or let us know, create an issue or something like this. Yeah, that's it, I think, from my side. Again, thank you for all my team, not my colleagues, and yeah, thank you also for the
Perfect.
audience. Yeah.
Perfect. Thank you. So maybe before we close this off, we just kind of like bring up a few comments. So Mechatronica, thank you. It is great
Yeah.
work. Node-RED is a great tool, right?
Yeah,
And
I think it's a Brazilian, looks like.
yeah, and then we've got Russell, I think is commenting on Dr. Rian's earlier question, right? Saying
Hmm.
supervised learning has a lot of promise where sensor or equipment specific semantics are predefined from a vendor by user with or without industry standard semantics. The model building isn't completely open-ended. Okay, so thank you so much, Charles, for taking the time out to come through and present your project with us. And to all members of the community who are on this call or watching this video, would like to get your feedback on the project. And again, this is something that is heavily under development, and it will really help bridge the gap between research and industry if we could provide as much feedback to the project as possible. So thank you again. If you've got any more questions, we can still answer a few more questions before top of the hour. But if there are not any more questions, we can close this off. Maybe before we do that, Charles, what's the best way to reach you? So I know you've got your GitHub page like LinkedIn. What's the
Yeah,
best?
yeah, I
Yeah.
would say LinkedIn, or yeah, LinkedIn is the best way. I'm sorry I forgot to put the links here, but My name is Charles Steinmetz with this not so easy last name. So you can find me on LinkedIn and or directly on GitHub.
Okay, perfect. Thank you so much. So with that, we bring today's session to a close. So if you are new again to this channel, make sure that you subscribe and look out for more content every week. So thank you again and have a great rest of the day.
Thank you.